Hello everyone, my name is Sarah and I will be talking about modular arithmetic. In my previous presentation, I left you with some homework and it was to decrypt this. But what is this? What did it say? Well, I have to tell you that I encrypted it, assigning a number to each letter. I did it under this formula. Each of these letters is the inverse of a certain letter x in modulus 25 plus 28 in modulus 25 or modulus 25. So you might be asking, what was the assigning? So assign to each letter of the alphabet a number. So here you can see that P is 16, W 23, L 12, V is 22, and F is equal to 6. And I left you with the question, let's say, and I ask you to decodify it. But wait, you tried it, because it's so easy to come and get the answer, isn't it? So if you have tried it, well done. I am very proud of you. But if you haven't, well, at least you're here trying to get an answer. And that's the important part. So stick with me and I will guide you to the answer. But before that, there are some things that we have to see. We have to recall that B has a multiplicative inverse in modulus A if and only if the greatest common denominator of A and B is equal to 1. But have I checked that all this is true? Don't worry. I know for sure that all the letters that I've chosen here have a multiplicative inverse. But if you want to check that for yourself, you can do it. Also, we will use the extended Euclidean algorithm to find the multiplicative inverses. And lastly, we say that if T is the multiplicative inverse of P in modulus A, then T times P is congruent to 1 modulus A. For example, if I have 3 modulus 5, I know that 2 is the multiplicative inverse of 3 in modulus 5. But why? If I get 2 and times it by 3, I get a number that is congruent to 1 in modulus 5. But do you remember what congruent is? Congruent means that both numbers, this one and this one, have the same remainder when divided by 5. And as you can see, 6 divided by 5 has a remainder of 1, and 1 divided by 5 has a remainder of 1. So now, to calculate our multiplicative inverse, we're going to use the extended Euclidean algorithm and 7 columns. The first column A is going to be the value of Q, that is the quotient of the A over B division, times the value of B plus a remainder. Why? Because we know that A does not divide B, and they have a common denominator. So in our rows, A is going to be the first value, but in our next row, the value of A will be the value that was B. Same happens to B, but a little bit different. In our first row, B is going to be our initial B, but in the next row, it will be the remainder of the division A over B from the previous row. Q is always going to be the quotient of A over B from the row we are working in. R is obviously the reminder of A over B in the current row, and it always will be like that. And we have these three values, T0, T1, and then T2. These three values come from the best suit identity. I am not going to explain this here, but if you want to know, I will leave you some information later. This value is equal to T0 minus Q times T1 because it has a relation with the reminders in the Euclidean algorithm. So let's get going. Remember the formula and remember our table. First, this formula looks a little bit scary, doesn't it? So let's use the properties of modular arithmetic to simplify. We can see that x mod 25 plus 28 mod 25 or mod 25 can be a little bit simpler. X mod 25 cannot be simplified anymore. So it's just going to be x mod 25. Then 28 mod 25 can be simplified as 3 mod 25. So then we have this and all of it mod 25. See? Then when we simplify all this, calculate our modulus and take mod 25 as a common factor, we end up with x plus 3 modulus 25. It doesn't look that scary now, does it? So first, we need to find x. But how do we find x? Okay, let's say that T1 is the inverse of x plus 3 in modulus 25. Then T1 is equal to x plus 3. And therefore, leaving the x alone, we have the x is going to be equal to T1 minus 3. So using the table, let's get our values for P, W, L, V, and F. So recall the table, and we get P to 16, W equals 23, L equals 12, V equals 22, and F equals 6. Then we just have a little reminder here. And let's go ahead and calculate the first one. For P equal to 16. We know that 1 is the inverse of 16 modulus 25, but it's the inverse when R is equal to 0, which means that our remainder is equal to 0. So in our first row, we have A, B, our quotient, remainder, T0, T1, and T2. For our next row, what do we know? That our B is going to be our new A. That our remainder is going to be our new B. The quotient is going to be the same. So 16 divided by 9 is equal to 1 with a remainder of 7. Then these two values are going to change now. So as we say, T0 is going to be the T1 from the previous row. So T0 is going to be equal to 1. Then T1 is the T2 from the previous row, which is equal to minus 1. And T2, as we can see in our little reminder here, is equal to T0 in this row, so 1 minus Q, that is also 1, times T1, which is minus 1. thus giving us a result of 2. Okay. And we have to keep going because our reminder is not 0. So in our next row, then we know that our B is going to be our A. The reminder is going to be the divisor. Then 9 divided by 7 has a quotient of 1 and a reminder of 2. Then again happens the same with T0 and T1. So this is -1, and this one turns into 2. And with T2, we now have that it is -1 minus 1 times 2. This is equal to -3. So this is the new value of our T2. But again, our reminder is not 0, so we have to keep going. So I just wrote the next one. So we have 7, reminder that was 2. Our quotient, reminder, values of T0 that was previously T1, T1 that was previously T2, and the calculation of T2 based on this formula. Again, our reminder is not 0 yet, so we have to keep it going. And then we have our B, the reminder, and the rest of our values. My scores are not perfect, or rectangles in this case. Then, as here, we have that the reminder is equal to 0. So the value of T1 is our inverse. So we have that T1 is equal to 11. So using this formula, we get 8 is equal to x. Now, let's see what happens in this slide. We have our method, our little reminder, and we're going to calculate the inverse of 23 in modulus 25. We will have our first line, our A, our B, this quotient, reminder, the first row values of T0, T1, and T2. So we know that in our next row, we're going to have our B is going to be our next A. And our reminder is going to be our B. We know that 23 divided by 2 is 11 with reminder of 1. So T0 is going to turn into T1. T1 is going to turn into T2. And T2, according to our formula, is 1 minus 11 times minus 1. We know that this is 12. And our reminder is not 0, so we have to keep going. So now we have that our B is going to turn into our next A. Our reminder is going to be our next B, 1. Our quotient in this case is 2, and our reminder is 0. So T0 is going to be T1, so minus 1. T1 is going to be the previous T2, so it's going to be 12. As our reminder is already 0, our inverse is 12. So then we have that T1 is equal to 12, and x is equal to 9. Now, let's see what happens in the next slide. We have our message. Then we have our little reminder there. We're calculating the inverse of L, whose value is 12. We know that T1 is going to be the inverse of 12, which is 25, 1r is equal to 0. But if you recall, the inverse of 23 in modulus 25 from the previous slide is equal to 12. And we all know that if A is the inverse of B, B is the inverse of A. So we know that if 12 is the inverse of 23, then 23 must be the inverse of 12. And here we have this. So T1 is 23, so the value of X is 20. For our next slide, we have our method, our little reminder, and our value, V is equal to 22. So T1, when R is equal to 0, will be the inverse of 22 modulus 25. We have our little chart. We see that our B is going to turn into our A. Our reminder is going to turn into our B. Our quotient in this case is 7, and our reminder is 1. We know that T0 is equal to T1 from the previous row, T1 is equal to T2 from the previous row, and T2 is equal to T0 from the current row minus the quotient from the current row times T1 from the current row. And this is equal to 8. So T2 is equal to 8. Then we have our reminder is still not 0, so we have to still going. Then next, our B is going to turn into our A. Our reminder is going to be our B. Quotient is equal to 3, and our reminder is 0. Then T0 is T1. T1 is T2 from the previous row. As our reminder is already 0, we don't really care about T2 now. So we have that T1 is equal to 8. Therefore, X is equal to 5. Let's see what happened in the next slide. Don't worry, we're almost done. We're only missing one letter. This letter is the letter F. And F is equal to 6 in the table we have. So we have our little reminder, never forget it. And we're going to calculate the inverse of 6 in modulus 25. So we have our first line that is going to be 25 over 6. Our quotient is going to be 4, and our reminder is going to be 1. We know that T0 in the first row is 0, T1 in the first row is 1, and our T2 in this case is going to be 0 minus 4 times 1. So this one is going to be minus 4. What happened next? So our B turns into A, our reminder turns into B, quotient equal to 6, reminder equal to 0, T0 turns into T1, T1 turns into T2. Our reminder is 0, so our desired value is minus 4. But what happened now? We ended up with a negative T1, but don't panic. When we have a negative value, we only have to find its counterpart positive. In these cases, minus 4 in modulus 25 is turned into 21 modulus 25. But you will ask why. We just get this minus 4 and add it to the modulus. So 25 plus minus 4 is 21. So our t-value, so t1 is equal to 21. So our x is 21 minus 3, 18. If you recall, we have p was 16 and its x value was 8. Our w was 23 and its x value was 9. For our L, which was 12, the x value was 20. For the V, which was 22, the x value was 5. And lastly, but not least, for the F, that was 6, the x value was 18. Now that we know all this, let's go to our table and find the letters that match to the x values that we found. So we had 16 with x value 8, 23 with x value 9, 12 with x value 20, 16 with the x value 8, 22 with x value 5, 6 with x value 18, and 22 with x value 5. So we just go to our table and find this out. So let's see. The letter corresponding to the number 8 is H. The letter corresponding to the number 9 is I. Don't forget there is a little space here. Then the letter corresponding to the number 20 is T. Then we have H again. Letter corresponding to number 5 is E. The letter corresponding to number 18 is R. And the letter corresponding to number 5 is E again. So as you can see, this message up here just says hi there. It doesn't look that complicated after all. You can write your own secret messages. I decided to write mine with multiplicative inverses, but you don't have to do that. You can use simple modular operations. For example, if you were adding or subtracting or even multiplying. So good luck if you want to try it. So I'm Sara Guerrero. Thanks for your attention.